Hello everyone, this is Abhishek Agrawal from MATLAB Helper. Today I will be the host for this webinar. In this webinar we are going to see how can we 2D map our surrounding with the help of the ultrasonic sensor and Arduino, and we will be interfacing these two hardware items with MATLAB, and we will see how can we send the data over the cloud server, that is ThingSpeak, and we will be visualizing the data over the cloud server. So let's start with our webinar part. So, as we know, vision is one of the most exciting senses we can endow on our robot. The ability to perceive obstacles allow a robot to make an educated decision regarding the further movements. This video will specifically deals with the sensor. In our case, we will be using an ultrasonic sensor to create a 2D map of our surrounding. As we know, autonomous robot systems highly depend on their ability to recover durable spatial model of their surrounding from sensory information, and it can be used in robot planning and control. So all these abilities enable the robot to make its own temporary decisions based on the data collected by the sensor. So the data received by the ultrasonic sensor will be used to create a 2D model which of our surrounding. So now we will see the learning objectives, what we will be learning in this webinar. So first we will see how we can install the required Arduino support packages for MATLAB. We will be installing the required support packages for the ultrasonic sensor that we will be using, that is HCSR04 ultrasonic sensor. We will see about ultrasonic sensor and servo motors, and as we are going to visualize the data over the cloud server, we are also going to send the data over the cloud server. So we will be also seeing about the ThingSpeak, how we are going to create channels and fields in ThingSpeak. We are going to see the circuit connections for the sensor and the Arduino. Then we will program the Arduino for our ultrasonic map maker, and at last we will visualize the data over the cloud server, that is ThingSpeak. So these are the software and the hardware that we will be needing. We will be needing a MATLAB, a latest version of the MATLAB, a version that will greater than 2016, a MATLAB support package for Arduino, HCSR04 add-on for Arduino, and in terms of hardware we will be using an Arduino Uno, that is a microcontroller. We will be using an HCSR04 ultrasonic sensor. We will be using a servo motor, and we will be using a USB-B cable for connecting our system with the Arduino Uno. So this was all about the software and the hardware that we will be needing for this webinar. Now we will see about the ultrasonic sensor, that is HCSR04. So basically in this project we will be using an ultrasonic distance sensor. Basically what is the use of this? It generates ultrasonic sound waves that is beyond the scope of the human hearing, and it measures the distance by calculating the time required by the waves to hit an obstacle and travel back. So this is the similar principle that is used by bats. So the sensor HCSR04 is basically what guides the bot and takes all the readings. It emits ultrasonic waves which hits an obstacle and reflects back to the sensor, after which it calculates the distance between the bot and the obstacle. So as you can see, this is a emitter and this is a receiver. So this is a ultrasonic sensor HCSR04 that we will be using in this project. So as we can see with the help of this diagram, this is an ultrasonic sensor, and this is an emitter, and this is a detector. Emitter is emitting the ultrasonic sound waves. When the ultrasonic sound wave hits an obstacle, it reflects back. As you can see, the green waves are the reflected sound waves and the red waves are the emitted sound waves. And after hitting the obstacle, the ultrasonic sound waves are reflected back, and then it is being detected by the detector. So basically it uses this principle in order to measure the distance. So there are two circular structures placed on the sensor circuit board that are the main parts of this module HCSR04. So this parts deals with sending and receiving ultrasonic sound waves. So let me show you that. So yeah, so I was talking about these two circular modules. So this is a emitter and this is a receiver. So this is the main part of the ultrasonic sensor. So basically a short 10 microsecond pulse is needed to trigger input for the sensor to start the ranging. A short 10 microsecond pulse sends a wave of ultrasonic sound at a 440 kHz frequency, and it starts to then raise its echo. The range or distance of the sensor from the obstacle is calculated by the time taken for the reflection of the ultrasonic sound to reach the sensor. In simpler words, it is the time interval between the initial signal sent and the echo signal that is received by the sensor. So now we can formulate the formula. How can we calculate the distance? Basically, ultrasonic sensor first, it measures the time taken for the reflected signal to reach the sensor. So the formula for its calculation is d is equal to half t into c, where d is the distance, t is the time, and c is the speed of sound in air, that is around 340 meters per second. So as we know, distance is equal to speed into time, so it is t into c, and it is multiplied with half. As the ultrasonic sound takes some time to reach and then it gets reflected back, so it covers twice the distance. So it takes twice the time to go and come for. So we are multiplying with half. So this is the formula, that is d is equal to half t into c, to calculate the distance from the sensor to the obstacle. And as we know, this is an ultrasonic sensor HCSR04, and it is having 4 pins, that is VCC, trigger, echo and ground. The first pin, that is VCC, and the fourth pin, ground, are used for power supply. VCC is connected to plus 5 volt power supply, and the fourth pin, that is ground pin, is connected to ground. And these two trigger and echo pins are, the trigger pin is the output pin and echo pin is the input pin. From trigger pin we will send a wave of ultrasonic sound, and from the echo pin we will receive the reflected ultrasonic sound back. So this is the output pin, trigger is the output pin, and the echo is the input pin. So the advantages of using this ultrasonic sensor HCSR04 is that it is low cost and it can provide an effective distance to obstacles ranging from 4 cm to a range of 4 meter, and it also produces a traceable amount of data for interpretation. Now coming to the servo motor that we will be using. So this, on the right hand side you can see a servo motor. This is the servo motor. So basically it differs from a DC motor is that it can turn to a very precisely to a given angular position and hold its position there. So when a servo motor is given pulses of a specific duration, it moves to a corresponding angular position. It has a one neutral position and it can turn 90° in either direction from its neutral position. So it can give a resultant of 180° of motion. So the ultrasonic sensor will be mounted on this servo motor so that it can give a 180° reading of our surrounding, so that we can get a 2D map of 180° view, field of view. So the, and also we can see that servo motor has 3 wires coming out of it. The first wire is a ground pin that will be connected to ground. The second one is for plus 5 volt power supply. So basically these two pins will be for power supply, and the last orange one is for the signal pin to give the pulse from the microcontroller so that it can turn to a precise angular position. Suppose I want to turn a servo motor to a 45° or ultrasonic sensor to 45°. So I will send a pulse from the microcontroller so that for a specific duration, so that the servo motor turns to a specific degree. So this was all about the servo motor. So we will be using this servo motor and ultrasonic sensor. So combinedly we will be using both this component to get a 180° field of view and get a 2D map of our surrounding.
New to MATLAB? Learn to program from scratch with our free online course on MATLAB Fundamentals. Get free access to 35 plus lessons with detailed guidance and MATLAB codes. Watch the 2-hour long video materials. Build exciting matrix visualization with fantastic content on 2D and 3D plotting. Work on projects suitable for MATLAB beginners and create your own code. Successfully complete our course certification quiz and proudly showcase your skill after booking our certificate.
So this was all about the ultrasonic sensor and the servo motor to get a 2D map of our surrounding. Now coming to the ThingSpeak part, that is the cloud server. So basically what is a ThingSpeak? Basically ThingSpeak is an IoT analytics platform service that allows you to aggregate, visualize and analyze data live streams in the cloud. So basically ThingSpeak provides instant visualization of data posted by our devices into ThingSpeak. That may be a sensor data or any kind of data that we are posting to ThingSpeak. We can get an instant visualization. With the ability to execute MATLAB code in ThingSpeak, we can also perform online analysis and processing of the data as it comes in. ThingSpeak is very often used for prototyping and proof of concept of IoT system that requires analytics. So as we saw, it is an IoT analytics platform. Basically ThingSpeak is an IoT analytics platform. So what is IoT? So we will see about what is Internet of Things, that is IoT. So basically Internet of Things is an emerging trend where large number of embedded devices that as things or sensors are connected to the internet. So basically these connected devices communicate with people and other things and often provide sensor data to cloud storage and cloud computing resources where the data is processed and analyzed to gain important insights. Basically in today's day, basically the cheap cloud computing power and increased device connectivity is enabling this trend. So in this nowadays, the cheap cloud computing power and the increased device connectivity is enabling this kind of trend. So this was all about the Internet of Things. So now coming to the visualization. So at a high level, many IoT systems can be described using the flow diagram that you see on the screen. So basically this is a flow diagram of an IoT system. So on the left hand side we have these smart connected devices. Basically these devices collect the data and it may include things like wearable devices or wireless temperature sensors, heart rate monitors, pressure sensors, machines on the factory floors. It could be any device. And in the middle we have a data aggregation or a cloud where data from many sources is aggregated and they are analyzed in real time. Often it can be called as IoT analytics platform like ThingSpeak that is designed for a specific purpose. And on the right hand side of the diagram it depicts an algorithm development associated with the IoT application. Here an engineer or a data scientist tries to gain insight to the collected data by performing an historical analysis on the data. In this case, the data is pulled from the IoT platform into a desktop software environment to enable the engineer or scientist to prototype the algorithms, and that may be executed in the cloud itself or on the devices by smart devices itself. So an IoT system includes all these three elements and ThingSpeak fits in the cloud part of the diagram. So basically this data aggregation and analytics part is the ThingSpeak that we are going to use, and it basically performs it basically quickly collects the data and analyzes the data from the internet connected sensors or things. So this was all about the flow diagram of an IoT system. Now we will be seeing the key features of the ThingSpeak. So basically it is a free online data aggregation platform. It can be used to collect data from the sensors that are things. It can provide instant visualization of the data. It is also popular for people experimenting in Internet of Things. It can be used to act on the data. Example is that suppose I can also tweet a message to a person when temperature of a room reaches 35 degree. Suppose my room temperature reaches at 35 degree and I want to get an alarm. So I can get a message from the ThingSpeak, and it can be used to analyze the data. So MATLAB integration allows the user to run scheduled MATLAB codes onto the data coming to the ThingSpeak. So basically, ThingSpeak is a platform that provides various services exclusively targeted for building the IoT applications. It offers the capabilities of real-time data collection, visualizing the collected data in form of charts, and ability to create plugins and apps for collaborating with web services, social networks, and other APIs. So we will see all other things, how we can create a channel and how can we upload the data into the cloud server and how can we analyze the data in the cloud server itself in the later part of the webinar. Speak. Now we will see the circuit connection of the ultrasonic sensor, Arduino, and the servo motor. So as you can see on the screen, this is a HCSR04 ultrasonic sensor, and it is having 4 pins, that is VCC, trigger, echo, and ground. So VCC and ground are for power supply, so VCC will be connected with the 5 volt or Vin of the Arduino, and the ground will be connected to a ground pin. And I have connected the trigger pin with pin number 13 and the echo pin with pin number 12. So this was about the HCSR04 connection. Now I am connecting the servo motor. So as we can see, the brown one is a ground pin, so I am connecting it with the ground pin of the Arduino. The next one is a 5 volt supply, is for 5 volt power supply, so I am connecting this 5 volt with the 5 volt of the Arduino, and the orange one is the signal pin, that is I am connecting it with digital pin that of the Arduino, that is pin number 2. So this was the circuit connection of basic circuit connection, and we will be mounting this ultrasonic sensor at the top of the servo motor, that is on the shaft of the servo motor, so that we can get a 2D map of 180-degree field of view. So this was all about the circuit connection. So now we will see how we will be installing the support packages for the Arduino and the add-ons for the ultrasonic sensor and all. So now we will see the MATLAB. We will be opening the MATLAB. So currently I have opened the MATLAB window. So now we will see how we will be downloading the support packages. So in the home tab, I will be clicking on add-ons, and then I will be going to get hardware support packages. Yeah. Then I have already installed this MATLAB support packages for Arduino hardware. So in order to install it, first click on this MATLAB support package for Arduino hardware, and then you will see one install option here. As I have already installed it, so it is not showing it. So click on already installed, click on the install option that will be present here and install the support package. So after installing it, you will see the MATLAB support package for Arduino hardware will be installed, and it will show a tag here that is installed. So this way we can install the MATLAB support package for Arduino hardware. Then we have to download these add-ons for the ultrasonic sensor. So search here legacy HCSR04, sorry, HCSR04, and you will see legacy HCSR04 add-on library for Arduino. Click on this. Here you will see, here as I have already installed this add-on, you will see a install option here, and click on install to install the add-on library. But you have to do some extra work here. So here is the instruction how to install the ultrasonic Arduino library written here. So first we have to download the zip file from this link. So click on this link and install the ultrasonic library, and after installing the zip file, unpackage the zip into the local directory and name the folder to the ultrasonic, and then move the ultrasonic folder into the libraries folder inside your Arduino sketchbook. So if you are using Windows OS, then the default path is My Documents, Arduinos and Library. On Mac, this will be documents, Arduino and library, and similarly for Linux. So I have already done this, so I will show you. I am going to my file manager. I am opening my file manager. This is the documents, and then Arduino and libraries, and here you can see this is the ultrasonic library that I have already installed. So this here, basically first you have to download that zip file, unpackage the zip file, and name that folder to ultrasonic, and move it in this folder, that is documents, Arduino, and inside the Arduino you will find a folder library, and you have to move that folder here. So this was all about the installation of the ultrasonic sensor library add-on. So now we have installed both the library. So now we will be starting with how to use Arduino with MATLAB. So sorry, I'm opening my MATLAB window. Now after installing both the add-ons, you have to check whether both the libraries are installed properly or not. So click on add-ons and click on get support hardware support package, and just a minute, it is loading. So you will see this MATLAB support package for Arduino hardware. Click on this, then you will find the option manage. Click on this manage option. Yeah, and you will see this MATLAB support package for Arduino hardware here that we have already installed. Click on the options button and click on setup, so that we can set up our Arduino properly. Yeah, so then connect your Arduino with your PC. I am connecting my Arduino with my PC, and so then we have to install the USB driver. So click on enable installation of Arduino USB driver in case you don't have any USB driver. Click on next, grant all the permissions by clicking on yes. So it will ask for certain permissions to make certain changes, so grant all the permission. So now it is asking, do you want to set up your Arduino board connection? Yes, click on next. Yeah, basically Arduino can be connected with the help of USB, Bluetooth or Wi-Fi. So currently the Arduino Uno that I am using, it doesn't support Bluetooth and Wi-Fi, so I am connecting with the help of the USB. So I will click on next. So now I will choose my board from this option. So this is, I am using an Arduino Nano Uno, so I will select Uno. I will select the port in which port of the computer it is connected. It is currently showing only one port, that is COM3, so it is connected, the Arduino is connected with COM3. Next it tells what are the libraries that you want to include in the server. So as we will be using a servo motor, so I am using this servo. We will be using an ultrasonic sensor, so I am ultrasonic sensor I will use. And as we have installed the library for HCSR04, I will include that too by clicking on this. Then we have to upload this program to the board, so click on the program, and you can see the program is getting uploaded to the board. So it might take some few minutes for that to upload. So now the program is getting uploaded. As you can see, the LED got brighter, that is the RxTX LED. So now you can see successfully the program has been uploaded to the Arduino server. So then now click on next, And yeah, now we can use our Arduino. It has all the included all the libraries such as I2C, HCSR04, SPI, servo for servo library and ultrasonic library, and then click on next. So this way we can set up our Arduino for our use. So yeah, it is open some help, no need to use it, close it. So this way we set up our Arduino Uno board with the MATLAB. So now we will program our Arduino board, and we will see the circuit connection for getting a 2D map using the servo motor and the ultrasonic sensor. So I will close this window. Yeah, and I will this was the process that were happening in the background. So all the it is all the various commands has been detected in the command window. So I will clear all the command window now. So this was all about the Arduino setup using the MATLAB.
Every training program administered by MATLAB Helper involves real-life situation and practical problems for you. These problems will help you in improving your thought-building skills. We train you with the latest advancement in the world of MATLAB and Simulink with our modules and raise your skills by improved industrial experience with logic and algorithm development. Book your slot for the MATLAB Helper training program today. You can join their training virtually or in office as per your comfort.
So this was all about the MATLAB, setting up the Arduino with the MATLAB. Before programming the Arduino for our 2D mapping using the ultrasonic sensor and the servo motor, first we will be creating the channels and fields in the ThingSpeak and creating an account for the ThingSpeak, so that after uploading the code we will be getting simultaneously we will be uploading the data to the ThingSpeak cloud server and visualizing the data there also. So now we will see how can we create a channel using the ThingSpeak. I am opening my internet browser. So I will go to thingspeak.com. So as you can see, you can see on the screen the ThingSpeak interface. So for I will click on get started for free, and first we need to create an account here, MathWork account. Where if you don't have one, create one. So I am creating one MathWork account. So first I will give my email address, that is Abhishek. So location, my location is India. First name, fill all the required details that is asking in the form, and click on continue. And after that we have finished creating an account. So it is telling we have got a mail in the inbox. So it is a verification link, so check this and click continue. Yeah, I have got a verification link, so I am verifying my email there. Yeah, I have verified my profile. Now I am clicking on continue. So I will write a password. So accept all the terms and conditions and click on continue. So as you can see, my sign up is successful. Click on OK. Now we can create channels and all. So I am writing student use and OK. Yeah, now as you can see, I have successfully created a ThingSpeak account. Now what you have to do is to interface any hardware or to get any information in this cloud server ThingSpeak. First we have to create a channel. So basically first we have to create a new channel for every time when we are using certain new things. Suppose today I am using this sensor. Whenever I need to create another IoT system, basically then we have to create a new channel. So I will click on create new channel. Yeah, so first I have to write the name of this new channel. Suppose I am getting as ultrasonic map maker. Then you can give any description to, I am giving the description as 2D mapping. Okay, then we have to mention the field names. Suppose the data, number of datas I want to send to the server. Suppose in this case for the ultrasonic map maker, what I will be sending, I will be sending the rotation in degrees of the servo motor. And as I have to make a plot that will be a polar plot, and it will give a 180-degree field of view. It will have a, basically it will have a 180-degree field of view, and we will show the distance of the obstacle. So first, so I will be requiring two fields for this project. So first one will be degrees in angles, sorry, angles in degrees, angles in degrees. And I will be using another field for the distance. So click on this checkbox to create another field and overwrite it as distance in centimeter. So basically these two fields will be needed for us. So I have created these two fields. So basically these fields corresponds to the data that will be sent by a sensor or a thing to the cloud. So basically we can interface 8 types of sensor, or we can get 8 types of data in the 8 fields in a single channel. And there are many other options such as metadata. If you want to provide certain other descriptions, so you can give in this metadata. You can give certain text that will be appearing on the channel. Suppose if you want to show any website link, you can give your website link. You can give your link to GitHub. Suppose you also want to show the location, so that you can also show the location by enabling this checkbox and give your longitude and latitude, so that while plotting you can show the location of the sensors and all. You can also show the video. If you are using a public channel, if you are clicking on the video, and that specified video will be appearing on the public view of the channel. So this was all about the channel data. And after setting all this, so I don't want to give the location and all currently for now, so I will be using only the field data and extracting the data, and then we will be visualizing it. So now click on save channel. So now you can see, as we gave, this is our private view of the channel. So as we gave only two data, that is two fields, we specified two fields, that is angles in degrees and distance in centimeter. So the two charts have been created for the two fields. So when we will get the data to the cloud server, when we will be sending the data, we will be showing the graph here. In the y-axis will be angle, and it will, and the in x-axis it will be specified as date and time, at which date the data has been sent, or at which time the data has been sent. And similarly for field 2, in the y-axis we will be having a distance, and in the x-axis we will be having a date. So this was all about the channel statistics. So yeah, like this you can view the channel location if you have been given the latitude and the longitude in the channel setting. So this was about the private view. Currently we have enabled the private view so that no one else can view our channel. If we make it public, it will appear in the ThingSpeak site and anyone can view this channel. Currently only I am able to view this channel and all the data that we are receiving from the cloud server. Currently we are not receiving any data from the cloud server, so these two charts are empty, they doesn't have any data. So this was about the private view. So we also got a channel ID, unique channel ID here for our project. So if you want to make it a public, we can make this channel as a public by making this channel public by, you can go navigate to sharing option and you can enable it so that it will be a public channel. So this is about channel setting. If you want to change certain setting, you can do here, or add any other fields you can do by clicking on channel settings. And yeah, this is the important part, API keys. This is the right API key. When we are going to send the data, we will be using this right API key to send the data to the cloud server, to the ThingSpeak. Suppose I want to read any data from the cloud server, then we will be using the read API key. You can also create a or generate a new write API key, and generate also we can generate a read API key. So if you want it, you can generate it. So this was all about the API keys. Suppose I want to import the data from any data from a CSV file, that is, or a Excel sheet. I can choose the file name and I can upload the data, and we can view it in the ThingSpeak server. We can also export the data to a CSV format. The data we have received in the ThingSpeak server, we can also export it in a CSV format, and we can download the data into our system. So this was all about the ultrasonic map maker using the ThingSpeak. So we have successfully created our channel. Now we will see the MATLAB code, how we will be getting the sensor data, and we will be uploading it in the ThingSpeak, and we will visualize it. Yeah, one more thing I forgot to tell you, that currently I am getting these two data separately. We can also combine these two data in a single plot. So we will see later how we can do that. We can visualize many other things regarding that. First I will upload the data, and then we will, first after getting the data, we will see how can we visualize this to both these plot in a single plot.
The world we are accustomed to will not be the same anymore. COVID-19, which first appeared in December 2019, has spread to 200 plus countries. We at MATLAB Helper have decided to spread the do's and don'ts of COVID-19 along with our mission of developing the next generation of technology developers. Feel the impact of COVID-19 with MATLAB with our blogs of SIR modeling and webinar on data analysis, modeling and prediction. Participate in webinar quiz and see how much you know about COVID-19 and MATLAB.
Now coming to the MATLAB code. With the help of this script, we will be creating a 2D map of our surrounding, and we will be interfacing the Arduino with ultrasonic sensor and servo motor, and we will be creating a 2D map, and we will be also sending the data that we are going to receive from the sensor to the ThingSpeak cloud server, and then we will be visualizing the data in the cloud also. So first I will be in the first step I will be clearing the command window and closing all other tabs and clearing the workspace. Then what I will do is I will create an Arduino object with the necessary add-ons that I have to include. So for that, I will create a variable a, and in variable a I will create an object by writing Arduino, and inside the parenthesis I will write COM3, the mm, in which port our Arduino is connected. I have to mention it, so I am using it with COM3, so I have mentioned as COM3, and I am using Arduino Uno board, and I have to include the libraries that we are going to use. I am going to use the Jodrigo Tech HCSR04 library for ultrasonic sensor, and the servo library for the servo motor. This information you can get, like the COM number in which COM port you are connecting, by typing in the command window a equal to Arduino. You must first connect the Arduino, then you have to write in the command window. So as you can see, you have got the port in which your board is connected, you have got the board, the available pin numbers, available digital pins, available PWM pins, and also the libraries, the available libraries. So we are going to use both these two libraries, so we have included that. So by this way you can get all this information. So I am clearing this and also clearing the workspace. So yeah, then what we are going to do is we have created an Arduino object. Then we are going to create an ultrasonic sensor object. As we are using an ultrasonic sensor, so we have to create it. As it is an add-on, ultrasonic sensor package is an add-on package, so I am writing add-on a. As we are connecting ultrasonic sensor to Arduino, so with the help of the Arduino object a, and the library that we are going to use, Jodrigo Tech HCSR04 library, and the pin numbers to which we are connecting the ultrasonic sensor. I am connecting the ultrasonic sensor there are 4 pins of ultrasonic sensor. 2 are VCC and ground that are used for power supply, and 2 pins are signal pins, trigger and echo. So I am connecting trigger pin to pin number digital pin number 12 and echo pin to digital pin number 13. Then we have to create a servo motor object, and as servo library is an internal inbuilt library, so I am directly writing servo and mentioning the Arduino object A and connecting with pin number D3, that is digital pin 3. So this was all about the connection and creating the add-ons object, Arduino object with the necessary add-ons. So now we will see the code to rotate the servo motor and get the readings through the ultrasonic sensor. So we will rotate the servo motor from 0 to 180 degree, and we will get the ultrasonic sensor reading. When the servo is rotating for every degree, we will be getting a ultrasonic sensor reading. So first I am assigning a variable I equal to 1, and then I am creating a table, that is a matrix with having 2 columns. One column will be used for the angles, for storing the angles, and the other column will be used to uh, store the corresponding distance. So I will use a for loop here. So for I will mention the angle theta is equal to 0 is to 1 by 180 is to 1. So every 1 degree, so 0, then 1 by 180, 2 by 180, 3 by 180, it will go up to 1. So 180 by 180, that will be equal to 1. So it is a inbuilt library, so we have to mention the angles in that format. For like 1 degree, we have to mention it as 1 by 180. So this is an inbuilt function, so I have to use that. So I will write the position. So for every position, we have to write it as servo motor and the angle for the angle in which the servo has to rotate. So first it will go for 0 degree, then it will move 1 degree, then 2 degree, like that. So then I am creating another variable dist1 in which the distance of the obstacle will be stored. So read travel time is an inbuilt function to read the travel time. As we know, the ultrasonic sensor gives the time it takes to go and travel back from the obstacle, to go and reflect back from the obstacle. So it will give read travel time is an inbuilt function, it will give the time. And as we know, the formula for calculating the distance is half c into t, where c is the speed of the sound, which is 340, and divided by 2. And then we will pause for 0.1 second, and then we will calculate one more time, that is this 2. This is we are taking two measurements for, and we are going to average them for better accuracy, and we will record that angle and distance in the table. So I am reading another time, I am sending one more time, I am sending the ultrasonic waves and reading the travel time, and then I am calculating the distance. Now we will average the two distance for better accuracy. Then in the first column of the table we will store the angle. So we can't store theta as it is 0, 1 by 180. So what I am doing, I have created a variable I equal to 1. So first reading is for 0 degree, so I have done I minus 1. And in the second column we are storing the distance, as I am going to store the distance in centimeter, and this is giving in meter, as the speed of sound we are taking in meter per second, that is 340 meter per second. So what I am doing is, in order to convert the meter to centimeter, I am multiplying with 800 and rounding off to two decimal places. So this way we are storing the data, and then I am incrementing the loop. So this way, for every degree from 0 to 180 degree, we will get the distance and we will get the readings. Now what we will do, in order to improve the accuracy of the map more accurately, or in order to get the data more accurately, what I will do is, as first we have rotated the servo from 0 to 180 degree and we have got the sensor data. Now what I will do is, I will move the servo motor back from 180 to 0, and we will average the previous reading, that was from 0 to 180, and the reading from 180 to 0. So we will to get a better accuracy of the map. So like what we have done in the previous loop, it will be same. We will calculate two distance, we will average them, and then what we are going to do is we are going to average the table data, that is second column data with the data that we got now, and we will average it, and then we will increment the loop. So by using this to loop, we are going to measure the data more accurately. So first I am rotating the servo from 0 to 180 and back from 180 to 0. So this way we got all the data of the ultrasonic sensor. Now is the important part is that how we are going to send the data over the cloud server. After getting the data, we have to send it to the cloud server. So first I have to mention the channel ID in which channel I am going to send the data. In order to do that, first I have to write the channel ID. So the channel we have created, we will go to the channel. Sorry. Yeah. This is our channel that we created, that is ultrasonic map maker. I am just copying the channel ID. This is 1097795 and I am pasting here. And then as we have to write the data into our channel, so we have to use the write key, write API key. So I will open my channel and then I will go to API keys option. Yeah, this is my write API key. So I will copy the write API key and in this place I will just paste the key. Yeah, then I am using a user API key. I will tell you the significance of this user API key. The user API key can be found out by just click on the icon, go to my profile, sorry, my account, and sorry, not here. Go to my profile, yeah, and you will be seeing a user API key here. Just copy the user API key and paste the key here. So what is the use of user API key is that suppose whenever we are running our code, we have to delete the previous data. In order to delete the previous data from the channel, we will be needing a user API key. So this is the need of user API key. But to write the data in the ThingSpeak channel, we will be using the write key, that is write API key. So the use of user API key is only to delete the data from the channel. So every time we are going to run the code, we are deleting the data that we have previously stored in the cloud. So I am using this user API key, and these are the two commands that will be used to delete the data from the channel. So URL sprintf, and this is a URL API key, and a first number to string conversion is there for channel ID, and we are mentioning the user API key, and then we are requesting the cloud to delete all its data from the channel. So by using these two commands, we can delete the data from the channel. Then what we have to do is, in order to write the data to the ThingSpeak channel, all the data must have a timestamp. Like every column every row which we are posting in the ThingSpeak channel must be having a timestamp. So what I am doing is I am creating a default timestamp for every 1 minute. So what I am doing, I am creating a vector timestamp date time now minus minutes by 180. Suppose now it's 4:15 p.m. So suppose it's now 4:15 minus 180 minutes to 4:15 minutes. As we have total, we have 180 datas, like from 0 to 180 degrees total we are having 181 columns. So what I am doing, like I am taking the last 180 minutes from now and till now, I will create a vector, and then what I will do, I will merge it with the two tables. So I will create another table and we will merge the timestamp table 1 and table 2. So this way I am sending the data to the ThingSpeak channel, and then we are going to write the data to the ThingSpeak server by using a ThingSpeak write command. This ThingSpeak write command, it posts the data into the ThingSpeak channel. So we have to mention the channel ID. So what I am posting the data table. So we have written the timestamp and table 1 table 2. Basically we have to post the table 1 data and table 2 data in our two fields. So as they require a timestamp, so we created a third column in order to give a timestamp. So we are sending the data table to the ThingSpeak server, and we have to mention the write API key as we are writing the data to the cloud server, and write key, that is the write key. Yeah. So this was the method to send the data to the ThingSpeak channel. Now in order to view the polar plot, what we have to we are creating a polar plot. So we will be using a function polar plot, as uh, we are doing a table for we are creating a plot for 0 to 180 degree. So I am using the theta limit function from 0 to 180, and I am giving a title to our plot, that is map of the environment. And as the table 1 is for angle from 0 to 180 degree, so I am using it into pi by 180, and the second column specifies the distance. So we have to plot, basically we have to plot angle versus the distance. So this was all about the MATLAB code, and we saw the MATLAB code. And now I am opening my ThingSpeak channel that we have created. Yeah, this is our channel, that is Ultrasonic Map Maker. And as you can see, there is no data is currently available in the two fields. So now we are going to run our code, and we will see that the data will get uploaded in the ThingSpeak cloud also, and simultaneously we will get the plot here also in our own MATLAB PC system. So now first before running our code, first we will see the connection that we have done, and then we will be running the code.
Are you looking for expert assistance in a long-term project or thesis or something else? Are you letting MATLAB delay your project? Is MATLAB holding up your task? Choose our affordable research assistance plan to get direct assistance from certified MATLAB experts in your field. Get your research assistance plan to let us do the hard work in MATLAB while you do the hard work at your organization. You are just a click away from help. Book research assistance today.
So this is our Arduino Uno, and this is a servo motor. As you can see, this is the shaft of the motor, this is a servo motor, and this is a ultrasonic sensor. As I told you, the servo motor has 3 pin. The white one is a signal pin, and the red and the ground are for power supply. I have connected the signal pin with pin number 3, that is digital pin number 3. And this is the ultrasonic sensor. This is the VCC. Green one is for VCC, yellow is for trigger, orange is for echo, and the red one is for ground. So I have connected the trigger and the echo pin with pin number 12 and 13, and the VCC and ground are connected for power supply. So this was all about the circuit connection. Now I will be connecting the Arduino to my PC. As I connected the Arduino, it shows Arduino Uno detected. Now I will run the code, and we will see the servo motor will be moving. And so I am now running the code, and we will also see that now, as you can see, the ultrasonic map maker, the two charts of the channel, ultrasonic map maker has nothing, that there is no data in that in the both the fields. And now I will run the code, and we will see the result. So I am running the code. and as you can see, the servo is rotating and the ultrasonic sensor is rotating. So yeah, it took from 0 to 180 degree and back from 180 to 0 degree, and we can see that we have got a plot, and this this is the place where there was no obstacles present, and this was the place where there was a glass was present. And yeah, just give me a second. Yeah, this was the part where the glass was present, and this was the part where the glass was the present, and this was the place where there was no data. And this is a polar plot, and we got the data from 0 to 180 degree, and we got the data from 0 to, and the y in the y-axis, that is the polar plot, we are getting the angles from 0 to 180 degree, and in the x-axis it specifies the distance of the obstacle. So this was the part where there was the glass at a angle of around 150 degree from the mean position, and it was, we can also see the distance. So this was all about the map of the environment. Now we will see the data in the ThingSpeak channel. So I will create, yeah, so first I will refresh the page, and yeah, as you can see, we have got the data in both the fields. In the first field, it is showing the angles. It is a linear graph, as we are incrementing the angles from 0 to 180 degree, so it will be a linear graph. And this is the graph where it shows the distance of the obstacle. So now we are getting these two plots, but if we want to visualize these two data in a single plot, like what we have done in the MATLAB, like we want to get a polar plot. So in order to get a polar plot, we will do some MATLAB visualization. So in order to visualize the data and get a polar plot of both these two fields, so what we will do is we will visualize the MATLAB data with the help of MATLAB. So I will click on MATLAB visualization. Yeah, after clicking on MATLAB visualization, you can see a various options here. We can create a field to area 2D plot, we can create a 2D line plot, we can create a 2D line plot with y-axis on both left and right side. So there are various sample codes also present for plotting a histogram and all. So but we have to make a polar plot, and I don't see any options here for creating a polar plot, so I can write out my own custom code. So just click on the custom no starter code and click on create. Yeah, after clicking on this custom, we will write our own MATLAB code here. So for writing that our own MATLAB code, we I have written previously our code in the data visualization. So I am just copying this code. I will explain all the bits of this code. So I am copying this code, and I am just pasting the code in this area. So first I have to mention the channel ID from where I have to read the data. Basically now we have to read the data that we have posted in the channel. So I will be writing the channel data, that is, we can copy the channel ID from here. So I copied the channel id, I am pasting the channel id, and I want to get the data from two fields, that is field id 1 and field id 2. So I mentioned the both the field ids, and as we are going to read the data from the channel, so we have to mention the read api key. So this is the read api key. I am copying the read api key. Yeah. So and pasting the read api key. Now what, first I am reading the data, first I am reading the data uh, from the two fields. So in order to read the data, I will be using a command things pick read, and we will mention the channel id, field, number of points. As I am getting the data, as I have posted 0 from angle 0 to 180 degree, that means total we have posted 181 points. So I am writing as 181 points that we are reading, and the read api key. And then we are going to, and I am storing that in the variable data2. Next we will be reading the field id 2, that is field 2 data. So in order to read that, we will be using a inbuilt command, that is thingspeak read, and then we will mention the channel id, field id, and the number of points, as we are going to read 181 points. So I am using 181 points, and then mentioning the read api key. Then as I am going to plot the two data by using the polar plot function. So I am just using that data 1 into pi by 180 and data 2, and then title of the map, and I am limiting, as we have got the data from 0 to 180 degree, so I am limiting it from 0 to 180 degree, and then grid on function. So by this way we can do the MATLAB code for reading the data and visualizing it. I can in fact create a public URL, like I will save the data and will run, and we can get the polar plot here only. Yeah, I have click on save and run. So now you can see, sorry, there was a mistake from my side. This will be data 2 and this will be data 1. Yeah, and now you can see the map of the environment from 0 to 180 degree and the distance in the x-axis. So this was the part where we placed the glass, and I will show you the plot that we got from MATLAB, and these two plot is exactly the both the plots are same. This is the plot that we got from the ThingSpeak cloud server, and this is the plot that we got in our MATLAB. This is the plot that we got in our MATLAB, and this plot we got from our cloud server. So as you can see, both these plot are same. And in fact you can create a public URL in which you can view the data. Just copy the URL and paste the URL here. So as you can see, we can even get our plot in a URL. This is a public URL, and this is hosted by the ThingSpeak server. So we have got the plot. So basically this was the use of the ThingSpeak in our project, and how we can post the data from any Arduino, or we can even use the Raspberry Pi or any different microcontroller and post the data to the MATLAB. And we can also see over the cloud, we can send the data over the cloud and visualize the data in the cloud itself. And we can visualize the data in a distant place, as the if the microcontroller is connected over the internet, the controller will send the data over the internet to the cloud server, and we can visualize the data in the cloud itself from a distant place. So this was all about the ThingSpeak cloud server. So this is how we can use the support packages for the Arduino in order to get a ultrasonic map, a 2D map of our environment. And this is how we can visualize the data over the ThingSpeak channel and send the data over the cloud server ThingSpeak. So this was all about this webinar, and thank you for watching this webinar. If you have any query, please feel free to ask in the comment section or get in touch with us. Follow us on Facebook, LinkedIn and Instagram, and do subscribe to our YouTube channel. Education is our future, MATLAB is our future. Happy MATLABing!
Hi, I am Mano from MATLAB Helper. I want to thank you all for being part in our webinar, quizzes and courses. We are doing series of 5 webinars followed with live interactive sessions. I am hosting my webinar on Control System Designer Toolbox on 22nd of August. 5 best comments from my webinar and live interactive session will be awarded with free access to 1 premium course and certification on completion. Join with me to learn about plotting the border plot and step response in MATLAB and comparing the obtained plot with the plots that will be obtained from the predefined functions. Finally, designing a control system for some applications for the given design requirements using the Control System Designer Toolbox. Know more by visiting my webinar page. Test your learned skills with participation in our free webinar quiz.